All right, so welcome everyone to the Oqtane Community Standup for May 2026. Um, I have a bit of an agenda today as usual, so I'll talk a bit about recent releases and what the status is of the current release. Do a very short demonstration on some of the features that are in the current release, talk a bit about roadmap, um, some events that are upcoming, and then we'll have some time for discussion as well. Similar to, I guess, the prior meetings, I haven't muted the folks that participate in this meeting, but I would appreciate if you keep your questions to the end, and then we can handle those as part of the discussion portion. All right, so release updates. The last release, there hasn't been a release since the last meeting. So 10.1.2 was the last release, and that was on March 26th. After that release, we transitioned to working on 10.2. And 10.2, the theme is scale out. And this diagram was shared in the repo related to the scale out conversation a couple months ago. So this architecture approach of using a shared instance for storage. So all of the Oqtane application assets as well as content files can be stored in a shared storage location. And then you can scale out the number of web instances that you want to run to provide more scalability and higher performance. Obviously, Oqtane uses the backend database, and so that's a shared database. So that database is shared by all of the web instances that are part of the installation. And there's a variety of advantages to using this approach. It's just a very simple configuration to set up as opposed to having to have multiple storage locations, handling replication of files between them. It's easiest to have like one centralized location for storage. And then some of the like cloud environments, like obviously Azure, make it very easy to spin up additional web instances that point at the same shared location, so that you can very easily obtain greater scalability for your environment. The challenges that were part of the framework in order to achieve this, of course, were around caching, scheduled jobs, logging, and then the fact that in order to, when we install new modules or themes, you have to restart out the web instance. So in this case, if you're going to have multiple web instances, really you need to restart them all. We talked a bit about folder providers last time. So folder providers are also part of a scale out story, but they are not critical based on this architectural approach. Based on the fact that if you're using a shared storage, then all like the content files that are part of that shared storage are accessible to all of the web instances. However, you sometimes will run into scalability issues if you store all of your content files in one location. And so it is beneficial to have a folder provider concept where you can store some of the content files externally. And so that is like sort of not a requirement in order to do scale out with Oqtane, but it would be a nice to have. So a bit of background, I guess, on the caching aspect of things. So Oqtane currently uses the memory cache library, which is part of course, the .NET Core. Memory cache is an in-process cache. It doesn't support scale out. It doesn't support cache synchronization across the different web instances, meaning, if you have multiple instances and you change some data on one of the instances, the other instance isn't aware that you've changed anything, and it would continue to use the same cache that it has in process. And so there has to be synchronization when you're using multiple web instances. Microsoft does have another library called, or another feature called distributed cache, which has been around for quite a while as part of .NET Core. Distributed cache only supports distributed caching, so it doesn't support in-process caching. It only supports out-of-process caching. Of course, the most popular distributed cache is Redis. the challenge there is that if you are, perhaps just doing local development with a single instance, or, you don't have scale out needs, then you do not need a distributed cache. Sometimes you might be able to get some benefit from it, but in general, having that extra infrastructure that you need to set up isn't great, just in order to use Octane. So distributed cache isn't really a great option for us to use. In .NET 9, Microsoft introduced hybrid cache, and hybrid cache was intended to be a hybrid between both in-memory and distributed. However, after, I guess, the release of .NET 9, it was, I guess, discovered that hybrid cache doesn't support cache synchronization, which is kind of strange considering like that's one of the main requirements when you're trying to scale out. Is to have cache synchronization between the different web instances. Um, However, it doesn't support it currently. I have not seen like a roadmap for hybrid cache to add this feature or to improve it in some of the other ways that it's lacking. For example, hybrid cache is only it only has an API that works with asynchronous methods, which would make it very difficult to integrate into Oqtane because the back end of Oqtane uses synchronous methods for a lot of the repositories. Of course, Octane could be modified so that all of the repositories use asynchronous as well, but then you run into the situation where third-party modules are relying on those repository methods, and it would be a breaking change for all third-party modules. So it's not exact. Hybrid cache basically doesn't meet our needs for a few different reasons, which is unfortunate. And like I said, I don't see a roadmap for when Microsoft plans to improve hybrid cache. The main product or like manager, developer who was in charge of it was someone who worked at Stack Overflow originally. So I think he was hired by Microsoft to work specifically on hybrid cache. However, he was laid off by Microsoft last year as part of like one of their large like layoffs that they did. And since that time, I haven't really seen much investment go into hybrid cache. So the other option that we had available was Fusion Cache. Fusion Cache is a third-party library that was developed, I think, 3 or 4 years ago and has continued to be improved over time. It had many of the same original goals as hybrid cache, meaning that it was designed to kind of be the best of both worlds between in-memory, in-process caching, and distributed caching. So it does support both of those models. But even more important, it supports synchronous and asynchronous API methods. It supports cache synchronization. And it has a whole lot of other features in it as well, such as stampede protection, fail-safe, a whole bunch of features. So it's quite a robust caching solution. I've included a link to the open source project here. It's Ziggy Creature / Fusion Cache. There's a lot of really good documentation that the maintainer of the project has created. And so if you're interested in learning more about it, I would encourage you to go check it out. A lot of great diagrams and good sort of simple explanations about different scenarios that you have to pay attention to when it comes to caching. So rather than take a direct dependency on Fusion Cache, I introduced a cache manager abstraction class as part of Octane, which essentially wraps Fusion Cache. The cache manager has a much simplified API. It does still provide synchronous and asynchronous methods, but it only provides a few of the most common methods that you are going to probably need to use in your module development efforts. And I've also included some methods so that it can support multi-tenancy, according to the way that Octane supports multi-tenancy. And as an example, this would be like an API method called getCache, where you pass the alias And if you, of course, there's use tenant manager to get the alias. And if you pass that alias into get cache, it will format the cache key in a standardized way. Because if when you think about caching, you have to understand that um, the cache is sort of one large shared memory resource that the entire application installation is using. And in Oqtane, you have multiple sites. And so each of those sites will use keys to access values in the cache, but unless they're prefixed accordingly based on the site, then you're going to have cache collisions based on the key name. And so that's why it's important to think about multi-tenancy when you're using caching within the Oqtane environment. And so these API methods try to make it simpler for developers where you can pass in the alias and it'll take care of that for you. Fusion Cache has a huge number of APIs so that you can use it in many, many different ways. And so if you have the need to use API methods that are sort of outside the small list that the cache manager provides, you can still take a direct dependency on Fusion Cache in your modules, and then you have access to use any of the Fusion Cache methods that are available. So more about caching. So like I mentioned, Fusion Cache has a lot of different configuration options that you can set. The most common options are configured in the app settings.json for Oqtane, and they're exposed through the system info area in the user interface. And so you can actually modify the values for some of those settings in the system info area. Another thing that was done as part of this effort to introduce Fusion Cache is all of the cache keys. Key names were standardized throughout the framework to follow kind of a consistent naming pattern using sort of a prefix with a colon and then the ID number. All of the entity names follow a similar naming convention now as well. So that was just a sort of an opportunity to kind of clean that up where there were inconsistencies. Another thing that was done is every Oqtane installation has an installation ID, which is a GUID that is unique to that installation. That installation ID is created dynamically when you install Oqtane, and it's stored in the app settings.json file. And so that installation ID is automatically used as an additional cache key prefix when interacting with the cache. And the reason for that is in distributed caching environments. For example, like if you're using Redis, you might want to share the same Redis cache service across multiple Oqtane installations instead of having to have, separate Redis installations for each one, which will essentially like be a lot of extra work to configure and a lot of extra money to set up. It's actually quite nice to have a shared Redis instance that you can use. Of course, you can scale that up or down based on the memory requirements you have. But by using the installation ID as a prefix, it allows a distributed cache service to be shared across multiple Oqtane instances. And then the last thing about caching is distributed caching survives application restarts. And that's actually one of the big benefits of distributed caching, is that when the application restarts, there will be a version of the cached value that's stored in the cache service. And so during startup, it can reach out to the cache service and very quickly retrieve the cache value so that it's sort of a warm startup instead of a cold startup. However, the thing to be aware of, and I think this is probably not going to be an issue for most module developers, but this was an issue when it came to the Oqtane framework itself, that there are some activities that are actually dependent on startup. For example, when Octane starts up, it iterates through the bin folder looking for modules and themes, and it uses, reflection to see the capabilities of those modules and themes. And it registers services, in dependency injection. So it does a bunch of things during startup. Um, and then it caches the list of modules or themes. Um, so that logic doesn't work, of course, if you're using distributed caching. Um, because, if you installed a new module and distributed caching was enabled for that type of data, the old list of modules would be returned from the distributed cache. So in this particular case, regardless of whether a user has set up their environment to use distributed caching, for these types of collections, they're only going to use in-memory caching, and ignore distributed caching. Um, Anyway, so it feels in some ways like over the past month or so, there hasn't been a lot of activity in the Octane repo. Um, but I think there was more work than I was expecting to try and understand the nuances of how caching should be integrated into Octane in the optimal way, and how some of the existing logic would be impacted by adding caching. Right? You can't just like add caching and it just lights up and magically works everywhere, right? You have to actually think through each scenario. And so that took a bit of extra time. When it came to testing the capabilities that were added around caching, um, obviously Redis is a very popular distributed cache option. However, Redis is not something that you can install directly on a Windows machine. You pretty much would have to install it in a container if you have your machine set up in a containerized way, or you could also interact with like a remote service that's maybe running Redis. But one thing to be aware of is that Microsoft Research released a project a couple of years ago called Garnet. Garnet is a .NET native distributed cache server. So it can be installed on Windows without any difficulty. Um, for whatever reason, it hasn't been widely promoted. Um, you can, if you do a search on it, you can find some information about it. In fact, it even claims that it's faster than Redis, so more optimized than Redis. And the really interesting thing about it is it truly is like a drop-in replacement for Redis because it uses the same protocol that Redis uses. So your application doesn't have to have any code changes whatsoever to use Garnet as opposed to Redis. So that's quite powerful. So anyways, in terms of like my local development, I was able to like pull down the code from the repo for Garnet, build it, and then you just run it locally. And it works great as a distributed cache that you can use for development. You could also use this in production. The other thing is you often want to know kind of what's going on behind the scenes when it comes to distributed caching, like what cache items are actually being created. Like so that you can validate that the distributed caching is working the way that you expect it to. So Redis Insight is a nice tool that you can install. I'm obviously using a Windows environment, so I installed it on Windows, but it allows you to have like a desktop kind of based application, a utility that you can connect to any Redis instance. And not, and like I said, because Garnet uses the same exact protocol as Redis, it actually works with Garnet as well. And it allows you, it's basically like a like it provides similar features as what like SQL Manager does for SQL databases, right? It allows you to connect to a distributed cache service, and then look at the cache keys that are in that service and manage them even. Like you can change their expiry dates, you can delete cache entries. It's quite a nice tool for that. All right, so that was sort of an overview of the caching improvements that have been worked on so far as part of the 10.2 release. Another aspect that I mentioned in the architecture diagram is around the identification of specific web instances that are part of your environment. So the website underscore instance underscore ID is an environment variable that Microsoft Azure uses as part of its app services to identify a specific web instance. So not just like a server within your environment, but the actual web instance that's running. Because like in a virtualized environment, you'll have multiple web instances, and they all may be on the same exact server. So you need a way to uniquely identify them at a lower level of granularity. So I believe that other um, hosting providers and people that provide sort of like a web garden slash scale out capability have also standardized on using this particular sort of environment key to identify web instances. So it should work outside of Microsoft Azure as well. And so capturing this information when it's available and storing it in the event log. So like when an event occurs within the Oqtane framework when it's running, you want to know what website instance it occurred on. And so that information will be logged in the event log. It'll be logged in the job log for scheduled jobs. And in the system info area, you can, of course, navigate there and it'll tell you like just what the current instance ID is. So that's been added to the framework as well. Scheduled jobs are obviously a pretty important part of the Oqtane framework. And I mean, it turns out that because scheduled jobs are managed in the database, which is a shared storage location, there already is a built-in kind of orchestration capability for scheduled jobs, meaning there was already the ability to check whether or not a scheduled job is executing or not. And that can be used to ensure that a job is not executed on more than one web instance simultaneously. Right? Because if a job's already executing, the another web instance within the environment doesn't need to execute it. So it already has sort of this built-in orchestration. Um, there was like in the previous meeting that we had, I was talking about that the scheduled jobs may need to be modified so that you could specify specific web instances which jobs should run on. However, after doing more research into this, well, and I should mention, like that was sort of the way that it was implemented within DNN. Like so, DNN supports scale out, I guess, like web farms. Um, and the way that DNN supported web farms was you could specify a specific server that a scheduled job was intended to run on. That was not always like it didn't always work as expected. And that's partly because, especially in the new cloud environments, these web instances are actually spun up and torn down dynamically, right? Often, if you're using like an elastic approach for scalability, which is obviously observing sort of the load that's on your environment, there isn't a specific ID that you can tie a web job to because that web job may be torn down and replaced with a different one, next in the next hour. So that's not a very good approach for doing this in the modern cloud environment. And so that didn't need to be implemented. And instead, there was, so in some situations, like for example, when a web instance is torn down, depending on how it happens, it might not happen gracefully. And when it doesn't happen gracefully, it means that a scheduled job will stay in the executing state in the database. And then after a restart, the system will come back up. And when it tries to run the job, it'll see that it's already executing, even though it's not. and it'll think that it shouldn't run the job. And so there was some logic that was in the hosted service base previously, which could kind of do an auto reset or some auto healing, right? So if it could detect that there had been a restart and a job was supposedly still executing, it knew that, of course, that was not in a logical scenario, and it would reset the job to say that it wasn't not executing, so that it would then execute on the schedule properly. Once you move to an environment that has multiple web instances in it, you can't just rely on the fact of the job starting up to indicate that it's not executing or is executing, because it may legitimately be executing on a different web instance. And so because of that, they had to introduce sort of a new set of logic with a maximum duration for a job, which basically says like this job will only like ever run for 30 minutes, let's say. And if it's been running for more than 30 minutes, then it's probably not running. Or something like some illogical scenario has happened in the environment and it should be reset. And so this can provide sort of that auto healing capability to reset jobs when, because the alternative of not having this kind of a feature is that a job would stay in this executing state and like none of the web instances would run it. And you wouldn't know that that a job isn't running the way it's supposed to. And because that's the whole purpose of a scheduled job, is to run without having to monitor it constantly. So this should take care of that scenario. Folder providers, I've kind of already mentioned that they're not entirely necessary for scale out based on the architecture diagram that I showed earlier. It's beneficial to store content files elsewhere sometimes to relieve the burden on the web instance. Ben Zhang did submit a PR already for this. So it contains an implementation for folder providers, but it hasn't been merged yet into the dev branch because it is a massive PR. I can't remember how many files are involved in it, but it's a huge PR. And so it's going to need some decent review and testing. All right, so as far as demonstration goes, I don't really have much to demo today, but all right. So in Visual Studio, one thing I will show you is so there's a new during startup, of course, the new caching capability needs to be registered with Fusion Cache, and so there's a new add caching method that's been added. This is called as part of the sort of add Oqtane and use Oqtane kind of methodology. And so once someone so if you're using the new Oqtane application approach, where in order to upgrade your, to the latest version of Oqtane, all you have to do is update the NuGet version numbers, just like any other NuGet package. So you'd update the NuGet package version for Oqtane to 10.2. This add caching will automatically be part of the startup logic that gets run. So you get the benefit of the new caching capability simply by changing the version number. Like I mentioned, it's using the installation ID as a unique prefix so that you can share the same distributed cache amongst multiple Oqtane installations. There's a set of default configuration that is set by default if you haven't set anything explicitly in your config file. There's a new caching section in the config file, and if it is set, then it's going to get the values from there instead. And then, of course, the other settings that are set as part of the config file for whether or not you're using distributed caching, whether or not you're using scale out, you obviously has different configuration options. So if you're using a distributed cache, it has to declare a serializer because it's obviously these cache entries are being stored out of process. And so as soon as you go out of process, then you have to serialize data. And so it's using the text JSON serializer, which is part of the Fusion Cache library. And then you specify with distributed cache. It says with like Redis cache here. However, of course, like I mentioned earlier, it also supports Garnet. And once you use a distributed cache, you have to specify a connection string. And I'll show you in the software where that's configured. And then if you're using scale out, then it uses something called a backplane as well. And the backplane is also leveraging Redis to do cache synchronization across different web instances. And so all those configuration options are set up within Oqtane itself. If we look at the app settings for this instance, like my local instance here, we have this caching section where we have the duration, whether or not you're using failsafe, whether or not you're using distributed caching, scale out, and then there used to be only one caching option before called cache control, but this is obviously related to static asset caching. If you're using distributed caching or scale out, then your connection string is stored here in the connection string section called distributed cache, and you would specify your connection string there. All right, so if I go ahead and run Oqtane, and I go into the system info area, one thing you won't see, because I'm not running in a multi-instance scale-out environment, you won't see the instance, like the website instance ID. Normally, like if you're running in a scale-out environment, it would be shown right after this server entry. So there would be some kind of an identifier that would show the instance ID, and it would show up here. If I go into the options area, we have this caching section now, and we can see that the default cache duration is 10 minutes for cache items. By default, it is using failsafe. And so this is a feature of Fusion Cache. Failsafe basically means that when a cache entry expires and it needs to refresh the data from the database or from another source, but quite often it's the database, and maybe something happens, like an exception occurs during that operation, it will fall back and use the existing cache entry for, I think it's set for like 1 minute, right? So it gives you, so if it was sort of an intermittent outage, or maybe the database was offline temporarily, or the database was too busy at that point in time when it tried to get the cache entry, it basically keeps your system up and running, and then it will subsequently try again. And it has like a certain number of times that it can keep trying before it will just fail altogether. But it's kind of a nice feature that's part of Fusion Cache, so it's included in Oqtane by default. So I'm not using distributed caching at the moment. I'm not using scale out. And so in this particular like configuration, this is basically just using memory cache like Oqtane has always used, and all the information is stored in process like you would expect. All right, so let's close this for a moment. All right. And I'm going to fire up my, like if I look at this, it's my Garnet server. So this was, like I said, I downloaded the code for Garnet, I compiled it, and it creates an executable, and I can run that executable. So if I run it, it runs in a console window, and it says I'm running Garnet version 115, and it's ready to accept connection. So now I have a Garnet, like a Redis distributed cache running on my device. I'm also going to fire up this, the Redis viewer, and I added my local database, right? My local basically environment to this. By default, Redis and Garnet use the same port number, 6379. And I'll show you this in a moment. So that's up and running. I could change the, so let's say we're going to use distributed caching. All right. So if I run this now, it's up and running. And if we go, I guess I could have changed it through here, but we can see in here that I'm using distributed caching. And because I am using distributed caching, it shows another option here, connection string, which I pulled from the connection string section in my app settings. And so that's my connection string. And if I go into my Redis viewer and I open it, I can see that there are cache entries which are stored. So this is the installation ID of my Oqtane instance. And then I have a site key, site number, well, there's tenant colon site. And then here's my HTML cache keys for the HTML module instances that are in my, that are cached with a distributed cache. I have some permissions that are cached. I have my current user, which is the host user cached. I have user roles cached. So you can see some of the cache items that are here. We also have cache items that are not specific to a site, right? These are host level caches, right? So the list of aliases and the list of tenants. So that's why they're not stored within this sort of site key naming convention. But they still have the prefix from the installation ID. All right, so by using this, you can see that like distributed caching is working. So one thing I can show you is if we go into, maybe we'll look at, we'll go into the services and we'll go into the site service. All right, and we'll go down to here. Okay, so this is a pretty common method that gets called within Oqtane, right? Get site. It's got a fairly large amount of data that's part of it. And so it's using caching to get the site with the specific site ID out of the cache. So I will, and it's calling this method as part of the factory, right? So if there's no cache entry, it's supposed to call this entry here if there is no cache. So if I go back to, oops, that's what I wanted to do. If I go back to my instance here and I'm clicking around, it's pulling the information out of the cache, right? It's pulling it out of the in-memory cache currently. So it's not going back to the database to get that information. That's why my breakpoint's not getting hit in my code. However, if I stop this, oh, sorry. If I stop this from running now, right? So my browser, I closed my instance is no longer running of Oqtane. And now if I fire up Oqtane, you might think that it's going to, like during startup, that it's going to call this method because there is no in-memory cache. However, because I am using distributed caching, it's actually going to go to the distributed cache server and get that cache entry out of the distributed cache and not hit the database. So that's the benefit of using distributed caching, right? It didn't hit the database at all. It went to the distributed cache. And it grabbed the which site key here? So it grabbed this site entry here, and grabbed all the data that was related to that, and so it didn't have to hit my database. So that's a way that using distributed caching can actually save your environment a lot, like time during a restart, right? It's a more of a warm restart than a cold restart. All right, so that kind of shows you a little bit about the distributed caching. Um, One thing I should explain here is if I go into this caching area, um, so by default, with hybrid with Fusion Cache, you're using memory caching, right? You would always use memory caching. Memory caching is the fastest form of caching available because it's in process, right? And so you have no ability currently in Octane to turn that off, right? By default, it will always use memory caching. You have the ability to use distributed cache if you want to, but in order to use it, of course, you have to have a distributed cache server, whether it's Garnet or Redis. However, I can turn that off and I can say I don't want to use distributed caching. I want to use memory caching. However, I could also still be using a scale out environment. So the benefit here is like, so I'm using, in this case, I'm using a multi-instance scaled out environment. I'm using memory caching, and I do need to coordinate or synchronize the cache entries across the multiple, like the multiple web instances that exist in my environment. And so in order to do that, I say that I'm using scale out, and I still provide the connection string to my distributed cache server because it's this distributed cache server which is going to do the synchronization. However, in this case, it's not going to use that distributed cache server as a cache. It's just using it to synchronize the keys between the web instances so that the memory cache is coordinated. So that's like another way that this can be used or configured depending on what your needs are. So um, I guess there's not much else I can show you because I don't have a distributed environment set up. But if you were, if you went in the event log and you were in a distributed environment and you pulled up an event log entry, of course, the server has always been displayed here. There would be another entry beneath this that would say instance ID, and the instance ID would be displayed if you were in a multi-instance environment. Similarly, if you or in the scheduled jobs area and you go to look at a log, right now the server is displayed that a job ran on, but it will also show the instance ID as well. So that's how instance ID has been kind of incorporated into the UI. So you can see where various workloads are running in your scaled out environment. All right. I think that that's all I was going to show you as far as a demo is concerned. So I'll go back to slides now. So roadmap, obviously the release that's available right now is 10.12. I would expect 10.2. I mentioned that it'll be in Q2. May is obviously in the middle of Q2. I think it'll be released like in May. Because like and in the meantime between like 10.12 and 10.2, there's been a .NET SDK 10.06 and 10.07 release. And so I guess probably the sooner that we can have a release of Octane, the better. I may hold off on integrating the folder provider until like a 10.2.1 potentially, just so that because there are it's always good to try to keep up with the .NET SDKs because almost every one of them have security vulnerabilities that have been fixed in them. And I think the 10.07 fixes some vulnerabilities that were in 10.05. So anyways, I'm still trying to decide at what point 10.2 should be released. Upcoming events, I mentioned this last time that we were going to do another Trailblazer conference. The date was set for Wednesday, June 17th. The focus for this event is sort of generally on creativity and innovation in the Microsoft ecosystem, so mostly to do with .NET. We have quite a list of Microsoft speakers this time, more than we've had in the past. So I have confirmation from Daniel Roth to talk about Blazor, David Ortno to talk about Maui, Adam Ratson to talk about Aspire, Brady Gaster to talk about Squad, Jeremy Lickness to talk about the UI Essentials, which includes the Microsoft extensions for AI and a variety of other AI related libraries. And so those are all the Microsoft speakers. We're still finalizing the community speakers that are going to be part of the list as well, but it should be a really interesting event. Our next meeting would be first Wednesday of June, June 3rd, same time, and open to questions at this point if anyone has questions about anything related to Oqtane.
Just want to bring something quickly up, Sean.
Sure.
Bootstrap 6 is coming out.
Yeah.
And I've already started looking at what that entails. It's going to be a big job. So just so you're warned.
Okay.
I'm doing it piece by piece. So as we do releases, or I get a chance to have a look at it, then I go through but there's actually quite a lot that's changing in it. So it's going to be a nice task. That's for sure.
Okay. So, and like obviously when you're building themes and things, the theme can specify the specific version of Bootstrap they want to use. However, because the core admin functionality depends on Bootstrap classes, it makes it a bit challenging. So it's unfortunate that Bootstrap is introducing a bunch of breaking changes, is what you're saying.
There's yeah, but it's smart. I mean, what they're doing is needed, but at the end of the day, it's a lot of search and replace, to be honest.
Okay. Well, it's a
And
lot
then
of search and
testing,
replace.
obviously.
But if someone upgraded to the new version of Octane, which was using Bootstrap 6, it's possible that their modules or themes that they've developed on Bootstrap 5 will not
That's
look proper.
that's what needs to be tested. But they've always been pretty well. No, the last time when they would put all the BS prefixes in, that really broke. I think that was 5. That really broke old sites.
Okay.
Yeah.
Yeah,
So
so we'll have
yes,
to.
nasty.
Okay, so we'll have to be careful. And right now, so Bootstrap 6 is still in preview, right? It's not officially released
It's
yet.
still like an alpha code. Yeah, it's alpha-ish moving. Yeah.
Okay. Okay. Good to know. Dependencies are the bane of my existence.
Oh, God.
I guess for all developers, true. Yeah. Any other questions?
Yeah, about
So,
this the caching. I mean, this isn't going to upset anything to do with like a normal single web hosted site, is it?
no, no.
I
Yeah,
mean,
so
will
if
we see
you,
all the external all the data that we're currently seeing for the caching? Will that'll just probably say like the current website you're on, is it? Or
yeah, so if you're only using a single instance, then
yeah,
you would, by default, Octane is configured in that way, and it would just use in-memory caching, and there should be like no effect whatsoever
right,
on your existing site. And then if you have used the memory cache library within your own custom modules that you've built, those will continue to work just fine as well. You could choose to migrate to the new cache manager if you want to. It's not required. Um, but yeah, again, that it shouldn't, it's not a breaking change, right? If you wanted to enhance your modules so that they supported a distributed cache approach or multi-instance approach, then it might make sense to migrate to Cache Manager. Otherwise, you could continue to just use memory cache.
right. So for someone like myself doing external modules, then it's probably better to move over to the cache manager.
Probably because if someone
Yeah, right.
wants eventually decides to use one of your modules in a
Yeah,
distributed environment, then you'll just have that capability built in. Yeah.
yeah, right. That's cool. That's good to know. Good to know.
Cody, you have no questions?
I'm trying to think really hard about one, but I got to catch up on all this stuff. I'm sorry. So
No, it's fine.
lots of stuff to dig into. I really like where you're going with it, though. I'm paying attention to all the different details of how to set up the Redis and the distributed cache because I am interested in setting this up on one of the projects I'm working on. So this is exciting. I'll probably be helping you test some of this out shortly. Thank you.
Okay, cool. Yeah, the scale out capability was kind of on the roadmap for a long time, at least a couple of years. And so it's nice that it's finally being implemented. And it'll be like another sort of great capability for Octane for people who are maybe hesitant, like thinking that, oh, I can only run it on a single instance. I may have greater needs than that, and so Octane's, not a good fit. That should no longer be an argument once we get to 10.2, right? Because you'll have the ability to scale it out to handle like a large amount of load. So
That's a huge boost. Congrats.
all right. If there's no more questions, and I appreciate you all attending, and we will meet again next month. And in the meantime, I'll try to provide more status updates just in the repo about how 10.2 is evolving.
Okay, Sean. Cheers.
Thank you, Sean.
Yeah, cheers. Thanks, everyone. Take care.